There are no fences in the sky, there are no borders in the sky. The sky belongs to us all. It's perhaps the next great undiscovered wilderness. And our role at the Bayfordbury Observatory is to watch and watch over the sky. We have three roles at the university. One is education. We run an undergraduate degree here where you can study astronomy for a degree. The second is outreach, where members of the general public come and use these telescopes. And the third is research, which we'll describe to you a little bit later on.
I think one of the things we try to foster in the arts really is the idea that art isn't really just about self-expression. It's really about giving voice to and making visible things which we haven't looked at more fully. And astronomy is the very epitome of that. Astronomy is constantly making visible to us things which are not visible.
What's out there? Why is what's out there and how does it work? So we see all these amazing things in the night. It's interesting to find out what they are, how they got there, and where they're going to be in the future and how they work.
The atmospheric physics that we do here is studying very carefully what happens in the air above us.
The arts and the sciences have a kind of synergy in this respect. They cause us to consider and really reflect on the nature of phenomena, and also to see the extraordinary magisterium of things.
We've made an incredible contribution to finding alien planets, which is one of the most exciting fields in modern astronomy. We're finding new and exciting planets almost constantly now.
I'm Dr. Mark Galloway. I'm the Principal Technical Officer at the Observatory. I'm responsible for the equipment and the facilities here. Here we've got a website that hosts our all-sky cameras.
One is a nighttime all-sky camera, so it can be used, for example, for tracking meteorites or looking at other interesting astronomical events, while the other one is a daytime all-sky camera, which in turn allows us to look at various curious phenomena seen during the day.
So this is an example of a type of meteor called a fireball entering the Earth's atmosphere, which we picked up on an all-sky camera, and this typically would be the size of a house brick, and it'll be entering the atmosphere at about 22,000 miles an hour at about an altitude of 80 kilometres.
Here I've actually got one of the meteors which has made it down to the Earth. This is an iron-nickel one, so this would have come from the core of one of the bodies which formed the planets when the solar system was forming. So this is a piece of metal which is 4.5 billion years old. So this is older than the Earth. This would have come from one of the bodies which formed planets like the Earth. In much the same way that Earth has got a metal core, this would have formed the core of one of the early bodies in the solar system.
A place like this is actually starting to be coming into its own again, really, in that the telescopes that we've got here, and they're now being set up to be used in a robotic mode, which actually creates the opportunity to use them for time domain astronomy, as we like to call it. That means following up on objects that vary. They can be supernovae, they can be exploding stars called novae, all manner of changing things in the night sky, because the night sky is changing all the time.
Most of the telescopes here have digital cameras attached, but one of the thrills of astronomy sometimes is to just look.
So this is one of our automated telescopes, and instead of looking through an eyepiece most of the time here, we use what's called a CCD camera, and that's very similar to the digital cameras you have at home or on your phone, but it's a lot more sensitive and it only takes pictures in black and white. So to get colour photos, instead of just taking one shot, what we do is take lots of shots using different filters that only let a certain amount of light through, and then we combine those images together and we get a nice colour image.
We have an artist in residence scheme going, which is tremendously exciting. We've had a student called Reggie Valkenborough who did a degree with us. She specialised in pinhole photography and has actually done a solargraph, which is a rather beautiful, exquisite photograph, which charts the movement of the sun across the sky throughout the course of the year.
Some students, as a part of their undergraduate degree, undertake a year abroad, working at a professional telescope in a different country, and they can apply the techniques they've learnt on these telescopes to the telescopes when they arrive, and they can really hit the ground running.
I'm Liz Dodd, and I'm currently a research student at the University of Hertfordshire. I did my undergrad degree and I had a placement year in Tenerife in the Canary Islands. During my placement year in Tenerife, I had the great opportunity to go to La Palma and have a night observing at the telescopes.
We don't just use an observatory like this at night, we can use it during the daytime. I said earlier we looked after the skies, and what I had in mind, one of the things I had in mind was the atmospheric research that's done here.
We use the LiDAR to probe the atmosphere by sending a sharp pulse of light out and looking for the light that's scattered back from various things in in the atmosphere. We can profile the atmosphere and look very, very carefully at all of the constituents.
We are now on the building of the Science Learning Centre, and what we got behind me is an instrument called a sun photometer. Like some of our telescope, it's a robotic system, so it can do measurements automatically, either remotely or completely without human intervention.
Well, these days there's a growing opportunity for sites like this, with a set of telescopes that can be actually set up as robotic telescopes that can take advantage of any good weather that turns up. And in wider astronomy presently, there's a growing interest in time domain astronomy. Again, in fact, this is a subject that used to actually be even more popular in the past, but is actually coming back in a big way. And these telescopes now are able to do this and will be able to do some cutting-edge science.
So there you have it. That's our whistle-stop tour of the observatory. Look forward to seeing you here again soon.